All right, hey professor, we're going to talk about our implementation of Spider World. So let's start with level one here. You can see we have our buttons in the top left corner. You could do step, green, step, red, turn, step, step, blue. A little pop-up telling you congratulations. You can use these buttons to implement your moves, and as you press these buttons, it also implements the instruction list or adds the instruction list to the work area on the right side, which is really cool. You can play back your instructions by pressing the play button. And also based on the speed slider, you can actually have it go a lot faster, or you could have it play those instructions much slower as well, as you can see it's doing right now. We've also implemented 15 full levels. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. What's really cool about levels 7 through 15 is they are dynamic levels. So if you press the level over and over again, you'll see how the grid changes accordingly, and the diamonds also adjust their locations based on the size of the grid as well. We also have our directions button implemented by Logan. We have our restart level, which clears the instruction list and also resizes the grid. And then we have our drag and drop elements over here on the right side. So if we want to have the solution for level 11 here, the solution for level 11 is a repeat until wall, repeat until red, paint red, step, and then we have an end repeat. So this is kind of an implementation that we developed to graphically show that you're ending the loop. So you end the repeat, you turn, and then we'll end the repeat again. And this should be the correct implementation of level 11. We'll put it up to 10 so it's nice and fast. And there you can see you have completed level 11. So when it comes to what I did for the project, I did a lot of the backend implementation of the three singletons. So let's open up our UML here. So we will go here. So this is our UML. We have three singletons: our level helper, our instruction list, and our run are the three singletons that are referenced through a lot of the different areas of our project. And so that's the standard solution that we use very heavily. Level helper being a list of levels, instruction list being a list of instructions, and then run having all of our execution methods. Additionally, we use an observer and observables. So observables, we have our level helper and instruction list, which are observables, and then our observer is our world. So as we change the levels or as we add instructions, the world will then observe those changes and reflect that in the GUI. Additionally, when it comes to the game itself and the GUI, I really worked on these buttons up here and making sure that they update the levels accordingly, making sure the levels are dynamic. I also implemented this slider, so making sure that as we execute, the slider reflects the actual speed at which instructions are being run. And then I also implemented, lastly, the repeat instructions right here on the work area on the right. So I didn't implement the GUI necessarily, but I did implement the back end implementation of how that repeat until wall, repeat until color works, and then the end repeat, and how that is incorporated into our instruction list.
Hi, my name is Train. Here are the items that I worked on for Sprint 1. First item is I added the sound effects for when the spider completes the level with all the correct colors for the grids. And when the spider hits a wall, there's a sound effect. And when the spider doesn't complete the level. For example, it doesn't color all of the grids. So that's a try again sound effect. And Ishan and I was working on this item, on this loop item, where basically the idea is we put everything inside of the beginning loop and the ending loop. But there was some small bugs that are still persisting that we couldn't figure out in time. And yeah, so basically, instead of what we had in the game, we will have it wrapped around the beginning loop and the ending loop. That's the idea. So, and that's pretty much what I worked on for this sprint. Here is the complexity report of our project. Now, the cyclomatic complexity is very high, 29, because we had a lot of conditions and for loops in one file. And the number of lines is 1100 with logic lines of code is 715. So we left a lot of comments and blank spaces, so that the next person, when reading the code, can know when to begin and where to begin. So here's a demonstration of that. For example, in level helper, we have lots of for loops in world, and we search for if, a lot of for loops. There are a lot of conditions. So that's the thing that we should improve on, to separate the concerns and create more helper files or helper functions.
So this is kind of a look at what I did for sprint one. So for sprint one, I did some basic things like create spider.java as well as the cell.java that's used in the current implementation. And then I additionally, I set up the decorator classes as well as the interface code block and its decorator class, code block decorator, and to perform all of the different, I would say, commands that we wanted our spider to adhere to, either when running sequentially from a work area or on button click. And so this was what I did for sprint one. And we did go over this in class, but later on we decided as a group or Luis actually ended up creating run.java, which was able to run it sequentially right then and there, as you can see in this. And so what I ended up being tasked with for sprint two was that while the spider was able to run sequentially once all of the instructions were given, it wasn't able to run on simply just button click. So running one instruction at a time on the click each time. So that was my implementation of what I had to do. So what I did was I actually went into run, and instead of this function execute, which runs through all of the instructions sequentially, I created a separate function called run one instruction right here. And in that one, I basically just, every time there's a button click, right, in app.java, you can see that these are all represent all the different buttons. Every time there's a button click, I essentially, whenever there's a step, what I'll do is that I'll run one instruction with the temporary instruction for step and with a value called check F, just to see whether or not I have to initialize anything, if it's like the first instruction. So that is how I was essentially able to implement it. And I did that for step, turn, red, blue, green, all those buttons, black, all these buttons, I was able to do that. And essentially it's really exciting because what we're able to do now is when I run it, let me go ahead and share. I'm going to go ahead and show the new screen right here. So this is our current implementation. So what I was actually able to implement was when we do things like press step, it's actually able to move, and it adds it right here in the work area. When I press turn, it turns, step again, and then turn, let's do another step, and now we're going to press green. So that does that right there. Now turn, step, press red, right? And then we step, blue. And as you can see, it not only updates it, but checks to see if the puzzle has been solved, and it does that one by one every time you press the button. And what's even cooler is that once you do this, you can actually replay all of those instructions. So I can do this, and it will go through the whole thing and show it once more. So that is essentially what I was tasked with implementing in our sprint 2, and I was able to implement that.
So basically my part for sprint 2 was to keep working on the GUI, specifically the work area, where you drag and drop the blocks to make sure that the visual lines up and connects with the actual functionality that we were hoping for. And that was a few different things: added the trash can, added restart level, added these buttons, creating blocks over here based on what labels were dragged. So for example, step green, paint green, step again, and then you could paint red. That shows up here, and it works here, but it'll loop around. This is the same functionality that's in the actual spider world. So turn, step, step, blue. That should be the correct instruction list. So we'll click play. You see over here, congratulations, you completed the level. And then restart level clears that. And if, for example, I have this here, and I want to get rid of this, drag it to the trash can, click play, and all it does is step. So that trash can, the functionality works. It works with different instructions. Paint black, so now we're going to step, paint blue, paint black's gone. Yeah, so that's pretty much what I worked on in sprint 2. Basically, this time we did a lot better. July 28th is today, so it looks like we just shifted it over, but should this have been a full week, you would have seen a more gradual slope. But because it was literally 2 days of work that we had to finish this, we didn't do anything the day of class, and then we started work here and started finishing work here. So, you know, it would be, if these days were included, it would be a more proper burn down. And that's because we utilized Taiga a lot better. We learned from our last mistakes in this one, to make sure to update the task cards as we go. Additionally, we were utilizing GitHub a lot better this time. In the first sprint, we had some problems with pushing and pulling the out files, which caused configuration problems with the build. You know, your edits wouldn't be compiled, and so we had to fix that. Additionally, I'll just go over the metrics of our GitHub a little bit. We're having a little bit of a weird thing where Triet's edits are not showing up on the on here. As you can see, it says he's added 17 lines of code, which I'm not sure is true. But each of us here, 811 lines and 7 commits, 433 and 19 commits, and 1,640 commits. That includes some text files, but in general, it's a lot of code from Luis, and it's good to keep track of still.